विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ।
Hello listeners, you're listening to Vigyan Ki Awaaz podcast program on STEM popularization, catalyzed and supported by the Ministry of Science and Technology, Government of India and Media for Community Foundation. Project devised and designed by Dr. R. Sridhar and assisted by Ashish Tiwari. Local coordination and production, Professor Subramanian. Content writing by Priyanshu and post-production by Professor Kaushik P. Kanchan of Garden City University, Bangalore.
Garden City University, conquer we shall all adversity. GCU, emphasis on life. GCU, emphasis on life.
Today, we are featuring a visionary leader in the field of nanoscience, Dr. BLV Prasad. Recently appointed as the Director and Chairman of the Center for Nano and Soft Matter Sciences in Bangalore, Dr. Prasad brings over 2 decades of pioneering work in nanomaterials and chemistry. A senior principal scientist at CSIR-NCL Pune, he hails from Vijayawada, pursued his PhD from Hyderabad Central University, and completed international postdocs in Japan and the US, including a NASA-sponsored project. With over 125 research publications and 8 global patents, Dr. Prasad's contribution spans continents, and his influence is felt in labs from Tokyo to Kansas. Stay tuned as we explore his scientific journey and his vision for the future of nanoscience in India and beyond.
My name is Prasad, BLV Prasad, and I am right now currently the Director of Center for Nano and Soft Matter Sciences, which is an autonomous institution under the aegis of Department of Science and Technology, Ministry of Science and Technology. This particular institution came into existence in 1991, started by a pioneering scientist, Professor Sivaram Krishna Chandrasekhar. And he was a pioneer in the area of liquid crystal research, which also comes under soft matter sciences. And I became the director of this center in 2021, and prior to that, I was at National Chemical Laboratory in Pune as a chief scientist for about 20 years. Okay. My field of research, I have a specialization in chemistry. I did master's and PhD in chemistry from University of Hyderabad. And then a couple of years I went out as a postdoctoral fellow to Japan and United States of America. And in 2003 I came back and then joined NCL. And as I said, 2021 I moved here as the director of this lab. My area of research is in materials preparation or synthesis, right? And I prepare them by chemical methods, which are also known as bottom-up synthetic methods, which are slightly different from physical methods, which are known as top-down synthetic methods. The challenges of material synthesis in bottom-up methods is always, while there is a greater control on material characteristics like properties and their features, very difficult to make them in large scale. So we focused on that, how to make large scale, because industry needs the materials in large scale. While in the laboratory we make them in milligrams, the industry needs them in megatons. Right? How to bridge this lab to market gap is what we wanted to address. And working in collaboration with chemical engineers, we luckily could overcome these hurdles, and then now we have methods of making a particular class of materials called nanoparticles in larger scale. And for this we combine the methods of chemistry and continuous flow. Right? Both these, combining these two methods, we are able to make large scale. The second question that I wanted to address is that how we can contribute to the research or to industry and society at large in India. Right? Most of these advanced materials, unfortunately, we rely on imports. And this is a major problem. So we want to address that. How we can make our industry, and obviously for industry to take up, there should be intellectual property protection. So we need to find out processes that are not being practiced by anybody else, and yet they are novel and can be scalable. So we found some methods like this in the area of material synthesis, and we have been able to make, for example, a particular class of material called silver nanowires in large scale. And we are continuing that now with other materials as well, right? Large scale synthesis has been one of our forte or one of our strong points of experiences. The second point is that, how do we basically, in terms of where do we stand, right, in terms of world research. When it comes to fundamental science, we are very strong in material synthesis, right? And we are now focusing on advanced materials like high entropy alloys, right, or nanowires, or nanoparticle dispersions, what are called quantum dots, which have been given a Nobel Prize in 2023. So these are the class of materials that we are focusing on, which could be very interesting or have great application potential in catalysis, in electronics, in very advanced fields like quantum computing, etc., etc. So we are working on all these things. Again, I want to restate that, at a personal level, my focus has always been identify those materials that are very important strategically and try to make them in large scale by a process that can be intellectually protected, that can be translated to industry as well. So that is what I do. And at this center, right now, in this center is a very unique center because this combines two interesting fields called nanomaterials and soft matter physics, right? These are very contrasting fields, but we combine them again to create very interesting applications. For example, smart windows, a window that can act like a battery or a solar panel, so that the light that falls on the window can be captured, stored as energy, and can be used later on, right? Also, no need to have a curtain because the window itself changes colors or becomes opaque or transparent depending on your need, right? So such applications we are working on. Displays we are working on. Another important aspect that we are working on is green hydrogen, production of hydrogen, storage of hydrogen, and utilization of hydrogen. That is, some of our scientists are working. Sensors, how do we sense, for example, if there is a toxic gas that is being released in an industry, how do we sense? And many times these are not one gas, there are mixture of gases. How do we know what are those mixtures, what are the gases present in those mixtures? That is another thing that one of our scientists is very strongly working on. Another scientist is working on how do we sense movement, right? This is very important in patients who are under palliative care, right? A patient wants to tell you something but unable to tell, right? By hand gestures, if they just move, we will be able to know what they want, right? So these are the advanced things. I won't say these are available as technology, but these are available at a fundamental level. How do we tackle these problems? What is required for us to do this? So these are some of the areas that we are working on. Three major areas: large-scale synthesis, identifying advanced materials, identifying advanced technologies for which these materials have to be used. So this is what I am.
That was wonderful, sir. I want to know, in India right now, your research, how is it useful? Is it short term or long term, anything?
Yeah. So I think any country, its research has to be in two ways, right? One is it has a global relevance. The other one is it has a strategic relevance, right? Strategic relevance, let me explain to you what it means, right? For example, all of us use mobile phones, right? And these days, no mobile phone has a keypad. It is a touch screen. The touch screen is actually comes through a material called tin-doped indium oxide, okay? And this indium metal, unfortunately, is not so much available in our country, and therefore we are relying on imports, okay? So if tomorrow, wherever we are importing, those countries stop exporting those materials to our country, we will have a problem. So we need to have alternatives ready in case there is a problem, right? So this is strategic requirement. Right now we are okay, because we are able to get this material from somewhere, but tomorrow if there is a problem, we should be ready with alternative solutions. These are strategic importance. Though there is technology already available, strategically it is important that we are self-reliant. We are not dependent on anybody else. This is what Honorable Prime Minister also says about Atmanirbharata, right? Self-reliance. We need to be ready if in case there is any problem. The other one is we also want to be global leaders, right? Where are these kind of areas? For example, as I said, green hydrogen, right? Hydrogen, tomorrow if fossil fuels are not available, right? So anywhere, right? Globally they are not available, not just for India. Globally they are not available. What are the alternatives, right? Hydrogen is one of the alternatives. Hydrogen has three components. Hydrogen generation. Where do you generate hydrogen from? Abundantly water is available. So if you can split water, what is called hydrolysis of water, you can generate hydrogen. But it has to be market ready. It means the technology has to be inexpensive so that common man can afford that, right? Second one is hydrogen, unlike the fossil fuels, is not in liquid form. It is in gaseous form, right? How do you transport? It is a very lightweight material, right? To hold it in a container is very difficult because it can escape through any small leakage, right? So how do you contain it, right? Storage is very important. Then utilization. Hydrogen utilization is generally done through a technology called fuel cell. Fuel cell based buses are available, many things are available again, but they are expensive, so you need to bring them down to what is affordable to a common man. So this is globally relevant research. Similarly, quantum technology, right? So these are all globally relevant research where we also want to be as advanced as any other advanced country, right? So two areas, what is important for our country, for our society at large, farmers, all those things, there are some of those areas, there are globally relevant. Both these problems we need to simultaneously work on. That's what we focus again.
So you spoke a lot about research and technologies lately. So I want to ask, in India, where do we stand right now in research and technology?
So we have been making great progress, right? As you would have seen, we are probably fifth, sixth in many of these areas, right? Especially in material science research. We are third or fourth, right? Compared to the other countries, right? In terms of number of publications, patents, right? So at fundamental level, right, writing, discovering new things, we are doing good. What is probably lacking, and again the government is making a lot of emphasis on that, is that how do we translate this at lab, whatever is available, to be ready for industry, right? For this, both sides have to come together. Both the industry has to take one step forward and the academia has to take several steps forward, right? This is important, and this is where, if there is a problem right now, what I would feel is that we need to have more and more younger generation to come and pursue science as a career, right? That is what we seem to be lacking, right? We don't have so many people wanting to do fundamental science. That is probably because there are no career opportunities. So if good career opportunities, thanks to this startup, right, the focus on startup industries, or the focus on industrial based research, if we can create career opportunities, more and more people will pursue science, and then we will do very good, right? Right now we are doing very good, but the gap between the second and third is slightly large, right? First, second countries are somewhere there, and though we are third, the gap is large. So we need to bridge that gap.
You were listening to Vigyan Ki Awaaz, a podcast on STEM popularization, catalyzed and supported by National Council for Science and Technology Communication, Government of India. Tune in for more such episodes to Vigyan Ki Awaaz on this platform and also through Spotify, YouTube and Apple Music platforms.
आइए हम सुने विज्ञान की अनकही कहानियां।